Hello dear children. Last day we have seen about the value and zero of a polynomial. How to find the value of a polynomial, also to find the zero of a polynomial. In that context, I would like to make a correction. See, yesterday it was told that the zero of a non-zero constant polynomial. That is a polynomial, constant polynomial which is not zero. A constant polynomial, it does not have any zero. Why you know? The zero of a polynomial is that constant which makes the value of the polynomial 0. So for a constant polynomial, suppose you take the constant polynomial 3. What value of the variable will make the value of the polynomial 0? That is what value of the variable. It does not have any variable. But you can take, suppose you take it as any number, say 5 or 4. 4 raised to 0 is 1. So when you multiply 3 with 1, it is 3 only. If you take 0 also, 0 raised to 0 is 1. So 3 into 1 is 3. So it never becomes 0. So the value of the polynomial is never becoming 0. So for a non-zero constant polynomial, it doesn't have any 0. Just make that correction. There is no 0 for a non-zero constant polynomial. And every real number is a 0 of a 0 polynomial. Okay. Now keeping this in mind, we have a remainder theorem. Remainder. Remainder means what? It's not reminder, it is remainder. Remainder theorem. It's something related with the division. So let us go back to division. When you divide a number, the number that is divided is called as dividend. The number which divides it is called as the divisor. The answer what you are getting is a quotient, and sometimes you may get a remainder. So our concept is regarding this remainder. Now the division fact. How do you write the division fact as? See, earlier in lower classes, after doing the division, your teachers would have asked you to verify whether the division is correct or not. How you used to do that verification? You'll be doing with this format, isn't it? That is, dividend equals divisor into quotient plus the remainder. So this is called as a division fact. What is division fact? Dividend equals divisor into quotient plus remainder. Supposing I am dividing, say 15 divided by 4. So 15 I am going to divide with 4. Here which is the dividend? 15 is the dividend, 4 is the divisor. So 4 in 15 how many times? 4 3s are 12, a balance of 3. So how will you write this in this format? Dividend 15 is equal to divisor is 4 into 3, 12 plus a remainder 2. Is it correct? 4 into 3, 12 plus 3. Sorry, not 2, 3. The remainder is 3. So 4 into 3, 12 plus 3 equal to 15. Yes, it is verified. So this is known as division fact. Now we are going to apply this division fact for polynomials also. So let us consider a polynomial p of x to be divided by another polynomial g of x. So when a polynomial p of x is divided by another polynomial g of x, you will be getting a quotient. What you will write it as? Q of x, and sometimes you may get a remainder, what you refer as r of x. So here p of x is a dividend, g of x is a divisor, q of x is a quotient, and r of x is the remainder. This is all for the polynomial in which variable? In the variable x. Now coming to this division fact, how we can write this in case of polynomials? You can write p of x is equal to g of x into q of x plus r of x. Is it clear? So this is the division fact for polynomials. Now keeping this in mind, we will go for the next topic, that is remainder theorem. Now we are going to state the remainder theorem. what is the statement? Let P of x be a polynomial of degree greater than or equal to 1. Greater than or equal to 1 means it can be a linear polynomial, it can be a quadratic polynomial, it can be a cubic or any polynomial of degree more than 1, 1 or more than 1. So P of x, let P of x be a polynomial of degree greater than or equal to 1. And let A be a real number. This is the statement. When you say a theorem, it should be stated as it is to be. So I am giving the statement again. Let P of x be a polynomial of degree greater than or equal to 1. And let A be a real number. Now if this polynomial P of x is divided by a linear polynomial. Linear polynomial means it will be of degree 1. So if P of x is divided by a linear polynomial of the form, there is a form x minus a. What is our a? A is any real number. So if P of x is divided by a linear polynomial of the form x minus a, then the remainder is P of a. Is the statement clear? One more time I may say. Let P of x be a polynomial of degree greater than or equal to 1. And let A be a real number. If this polynomial P of x is divided by a linear polynomial of the form x minus a, then the remainder is P of a. The remainder is P of a. So let us write this statement as and how we have to write it as a division fact. How will you write? A polynomial P of x of degree greater than or equal to 1 is divided by a linear polynomial of which form? X minus a. So the divisor is x minus a into, you are getting a quotient plus a remainder x. Now I'll just give you the proof as how you are getting the remainder as P of a. Now since x minus a is a linear polynomial, that was a statement. Linear polynomial means its degree is 1. So the remainder will have a degree less than 1. What is a degree less than 1? 0. So what will this become? This will become as r itself. Why? Because x, the degree will be 0. X raised to 0. X raised to 0 is 1. So you can rewrite this as P of x equals x minus a into q of x plus r, where r is a real constant now. It has become a real constant. This is the fact now. Now for a particular case, when x is equal to a particular case when the value of the variable x is equal to the real number a, what will happen to this statement? X will become a. So P of a will be equal to, instead of x you will be writing it as a minus a into q of a plus r. So what is a minus a? 0. So 0 into q of whatever it is, the whole term becomes 0. So what remains? P of a is equal to r. Now what is r here? R is a remainder. So remainder is P of a. So this proof you need not learn. I just told you to understand how you are getting that remainder as P of a. So what is the statement? Let P of x be a polynomial of degree greater than or equal to 1 and let a be any real number. When this polynomial P of x is divided by a linear polynomial of the form x minus a, then the remainder is P of a. Is that clear? Now we will do some questions by which you will understand how we are getting the remainder. Now we are having a question here. Find the remainder when P of x equals 3x square minus 3x plus 2. So we are having the polynomial 3x square minus 3x plus 2 is divided by x minus 2. What is the remainder? So go to the theorem, apply the theorem here. You are having a polynomial p of x of what degree? The degree here is 2, greater than 1. Is divided by a, is this a linear polynomial? Yes, the degree is 1. So divided by linear polynomial, what will be the remainder? The remainder is p of a. Now just you equate this. What is this x minus 2? X minus 2 is same as our x minus a. Linear polynomial of the form x minus a. So what is the value of a here? X minus 2 is same as x minus a. So what is the value of a? A is equal to 2. So how will you find the remainder? You will be finding p of 2. That is, instead of x in the given polynomial, you will be substituting 2. And then finding, actually you are finding what is the value of the polynomial. So p of 2 will be equal to 3 into 2 square minus 3 into 2 plus 2. So 2 square is 4, 4 into 3, 12 minus 3 into 2, 6 plus 2. Now add the positive terms together, 12 plus 2, 14, 14 minus 6 is equal to 8. So the remainder obtained when you divide p of x, 3x square minus 3x plus 2 with x minus 2 is 8. You are getting a remainder. Now sometimes it so happens that the remainder will be 0. That is, p of a is 0. In some cases it may so happen. See, normally when you divide 15 with 3, what is the remainder? The remainder is 0. Same way for polynomials also, when you divide, sometimes the remainder may become as 0. Then what you can conclude from that? X minus a is a factor of the given polynomial. X minus a is a factor. See, 15 divided by 3, the remainder is 0. What does it mean? 3 is a factor of 15. Same application here. If p of a is equal to 0, then x minus a is a factor of the given polynomial. That is one conclusion what we get from this remainder theorem. If the remainder is 0, if p of a is equal to 0, x minus a is a factor of the given polynomial. So understood how to find the remainder when you are asked to divide. See, one more easier way I will tell you. See, suppose you are having this to be divided with the linear polynomial x plus 2. So you compare this. When you compare, what you are getting? X plus 2 is equal to x minus a. In that case, when you compare a, minus a is equal to 2. So what is the value of a? A should be minus 2. So in that case, you will be finding p of minus 2. If you have confusion in comparing and writing, there is another one easy method. What you do here is, you find the 0 of this linear polynomial. What is the 0 of the linear polynomial? How do you find 0 of a linear polynomial? Equate the given polynomial to 0. So how will you do this? X plus 2 is equal to 0. So what is the value of x? X will be minus 2. So instead of x, you will be putting it as minus 2. So in case you find difficulty in doing like this, sometimes some of you may find it difficult. You may go wrong here, because here it is positive. Here our concern is minus a. So there you will be taking it as a as 2 itself sometimes. But it is not 2, it is minus 2. So in case you find any difficulty in doing in this way, go for this method. What method? Finding the 0 of the linear polynomial with which we are dividing the linear polynomial. Is that clear? One more example we will do. The question is, find whether x plus 5 is a factor of p of x equals 2x cube minus 3x plus 2. What is the condition that we have learned? If p of a is equal to 0, then x minus a is a factor of the given polynomial. So first you will have to find the remainder. Find whether the remainder is 0. If the remainder is 0, then x plus 5 will be a factor of 2x cube minus 3x plus 2. For that, what you are going to do first? Find the 0 of the linear polynomial. So x plus 5, you are getting to 0. What is the value of x? X equals minus 5. Now what you are going to find? You are going to find p of minus 5 and see whether p of minus 5 is equal to 0. Let us do. 2 into minus 5 the whole cube minus 3 into 5 plus 2. This will be equal to minus 5 the whole cube. Minus, when you cube it, it will be still a negative number. And 5 cube, 5 into 5 into 5 is 125. So minus sign, when you are cubing, it will be again a negative sign. So this will be 2 into minus 125 minus 3 into minus 5. 3 into minus 5 is minus 15 plus 2. So minus 125 into 2 will be minus 250 minus of minus 15 plus 15 plus 2. So what will be this? Minus 250 plus 17. So minus 250 plus 17 means subtract and put the value of the greater number. So this will be 250 minus 17, 3, 233. So this will be minus 233. Why the negative sign? Because 250 is a greater number. So the remainder is minus 233. Is the remainder equal to 0? No, the remainder is not equal to 0. So is x plus 5 a factor of 2x cube minus 3x plus 2? No. X plus 5 is not a factor of the given polynomial. This is one application of the remainder theorem. Now, two more applications are there. We'll be doing that also. Now, you have a question here. The polynomial p of x equals kx cube plus 9x square plus 4x minus 8 when divided by x plus 3. The linear polynomial here is x plus 3 leaves a remainder minus 20. Find the value of k. Here, it is a variable given here, k. So, you are asked to find the value of this k. When this polynomial is divided by x plus 3, it will have a remainder minus 20. So, first what you have to do? You have to apply the remainder theorem. You are going to find the remainder. When p of x is divided by x plus 3, what is the remainder? And we are given the remainder is equal to minus 20. So, what remainder we are getting on dividing this p of x with x plus 3? You will equate that to minus 20. Then you will get the value of k. So, let us try doing it. So, x plus 3 is a linear polynomial. You will first find the 0 of this. You will equate this to 0. So, x will be equal to minus 3. Now, what you are going to find? You are going to find p of minus 3. P of minus 3 will be k into minus 3 the whole cube plus 9 into minus 3 the whole square plus 4 into minus 3 minus 8. You are going to find the remainder. This will be minus 3 cube. Minus negative sign, when it is cube, it is still a negative number. 3 cube, 3 into 3 into 3. How much? 27. So this will be minus 27k minus 3 square. Minus 3 square is plus 9. 9 into 9 is 81. Then 4 into minus 3. 4 into minus 3 is minus 12. Minus 8. So here you are having minus 27k, 81, minus 12, minus 8. You will first take the negative quantities together. Minus 12 minus 8 is minus 20. Plus 81 minus 20 will be how much? Plus 61. Sorry, plus 60. Plus 61. Minus 81 minus 20 is 61. Now what is given for us? This remainder, what you are getting on dividing p of x with x plus 3 is minus 20. So what is the remainder we got? Minus 27k plus 61. This reminder's value is actually how much? Minus 20. So you are going to equate this remainder to minus 20. So minus 27k plus 61 is equal to minus 20. Or minus 27k will be equal to minus 20. Transpose 61 to the other side, you get minus 61. Or minus 27k will be equal to minus 20 minus 61. You will add and put the negative sign. So it is minus 81. Or what is the value of k? Minus 81 by minus 27. 81 by 27 is 3. So the value of k is 3. Understood how to do this? This is one application of the remainder theorem. Now you have a question here. The polynomial kx cube plus 3x square minus 3 and 2x cube minus 5x plus k, when divided by x minus 4, leaves the same remainder. We are given two polynomials. Both of these polynomials, when divided by x minus 4, the same linear polynomial, leave the same remainder. Both of them will be having the same remainder when you divide it with x minus 4. If so, you have to find the value of k. You are having the two constants there, sorry, two variables k. What is the value of k? So what you are going to do? First, you will be finding the 0 of the linear polynomial. So equate x minus 4 to 0. You get the value of x as 4. X minus 4 equals 0, so x is 4. So 0 you have found out. Now what are you going to do? You are going to find the remainder when you are going to divide this polynomial with x minus 4. Then you will find what is the remainder when you are going to divide this polynomial with x minus 4. And then what is given for us? Both the remainders are same, which means you will equate both the remainders. From that you will get the value of k. So let us try doing it. So first one, p of 4. P of 4 for the first polynomial will be k into, instead of x you will be putting it as 4. So k into 4 cube plus 3 into 4 square minus 3. This will be equal to what? 4 cube. 4 into 4 into 4. 4 into 4 16, 16 into 4 64. So this will be 64k plus 4 square. 4 square is 16. 16 into 3 is 48 minus 3. Or this will be again equal to 64k 48 minus 3. How much? 45. So plus 45. This is the remainder what you are getting when you divide kx cube plus 3x square minus 3 with x minus 4. Now you are going to divide 2x cube minus 5x plus k with x minus 4. So how will you find? P of 4 will be equal to 2 into 4 cube minus 5 into 4 plus k. This will be equal to, again 4 cube is 64. 64 into 2 is 128 minus 5 into 4 is 20 plus k. So 128 minus 20 will be 108. So this will be equal to 108 plus k. This is the second remainder. Now what is the question? Both of them leaves the same remainder, means both these remainders are same. So what you should do? Equate the remainders. What are getting? 64k plus 45 will be equal to 108 plus k. Now you are going to bring transposing k to this side and 45 to the other side. So this will be 64k minus k. This k you are bringing to this side will become minus, will be equal to 108. 45 taken to the other side becomes minus 45. So 64k minus 1k will be 63k equal to 108 minus 45 is again 63 only. So what is the value of k? 63 divided by 63, which is equal to 1. So the value of k is 1. When the remainder is same, when you are dividing both these polynomials with x minus 4. So you understood how to do this. This is an application of remainder theorem. So today we have learned about the remainder theorem. Let us say the statement for the theorem once again. Let p of x be a polynomial of degree greater than or equal to 1 and let a be any real number. If this polynomial p of x is divided by a linear polynomial of the form x minus a, then the remainder is p of a. And I suppose you know how to find the remainder when you are asked to divide a polynomial with a linear polynomial. Is it clear? Okay, thank you children.